Hi, in this video I am going to discuss how to implement the Boolean functions using demultiplexer. Demultiplex means one to many. It is a reverse operation of the multiplexer. A demultiplexer is a combinational logic circuit with only one input and many outputs. It is also called as data distributor. It is a circuit that receives information on a single line and transmits this information on one of 2 power n possible output lines, and the selection of specific output line is controlled by the bit combination of selection lines. Demultiplexing is the process that receives information from one channel and distributes the data over several channels. This is the symbol representation of demultiplexer and this is the block diagram representation. And here the input is 1 and 2 power n outputs and n number of selection lines. And similarly, the block diagram representation is here. The input is one channel, the output is 2 power n channels and n number of selection lines. 1 to 8 demultiplexer. 1 to 8 demultiplexer, there are one data input line and 8 output lines. So 2 power 3 is equal to 8. So 3 selection lines are required to design the demultiplexer. So it distributes one input line to one of 8 output lines depending on the combination of selection inputs. So the 8 outputs are Y0 to Y7. The 3 selection lines are S0, S1, S2 and the data input DIN. This is the block diagram representation for 1 to 8 demultiplexer. This is the truth table for 1 to 8 demultiplexer. The selection lines are A, B, C and the 8 outputs are Y0 to Y7. Now the selection lines are 0, 0, 0. The output Y0 is selected. So the output expressions are represented as Y0 is equal to A bar, B bar, C bar, D. This product terms are implemented by AND gate. Next is 0, 0, 1 combinations. The output Y1 is selected. So the output expressions are A bar, B bar, C, D. Similarly, all the 8 outputs are returned. So for Y7, the selection lines are 1, 1, 1. So here the output expressions are A, B, C, D. So this is the truth table representation for 1 to 8 demultiplexer. This is the logic diagram representation for the 1 to 8 demultiplexer. The data input is D and the 3 selection lines A, B, C, and at this position we will get A bar, here B bar and C bar. And the product terms are implemented by AND gates. So this first AND gate output is Y0, second AND gate is Y1, Y2, Y3, Y4, Y5, Y6, Y7. So this is the way we can draw the logic diagram for all the 8 outputs. In 1:8 demultiplexer, the input line is DIN, the selection lines are S0, S1, S2 and output lines are Y0 to Y7. Each output we will obtain the min terms. The min terms Y0 to Y7 is represented. So here it's an 8 output. So we have 3 selection lines. So this is the block diagram representation for the demultiplexer. Implement the full subtractor using demultiplexer. This is the truth table for full subtractor. The inputs are A, B, C and the outputs are difference and borrow out. So the 3 inputs we can make 8 combinations. For the first combinations 0, 0, 0, the output is 0, borrow is 0. 0, 0, 1, difference 1, borrow 1. 0, 1, 0, difference 1, borrow 1. 0, 1, 1, difference 0, borrow 1. 1, 0, 0, difference 1, borrow 0. 1, 0, 1, difference 0, borrow 0. 110 different 0 borrow 0, 111 difference 1 borrow 1. From this we are getting the SOP terms. So for difference is 1247 and borrow is 1237. Now we are going to implement with 1:8 demultiplexer. So here this is the block diagram representation. The 8 outputs are Y0 to Y7. Each output we are obtaining the minterms, and these are the three inputs. The three inputs are given to the selection lines and the external input D in this one. Now to design difference and borrow, we are taken the main terms and connected to the OR gate. So the expression at this position is difference and here is borrow. For the difference, the expressions are 1, 2, 4 and 7. And for borrow, 1, 2, 3 and 7. So this way we can implement the full subtractor. Implement the full adder using 1:8 demultiplexer. This is the truth table representation for full adder. We have 3 inputs A, B, C and 2 outputs sum and carry. So from the truth table we are obtaining the expressions for sum and carry. The sum outputs are 1, 2, 4 and 7. The carry outputs are 3, 5, 6, 7. Now implement the full adder using 1:8 multiplexer. The full adder outputs are sum and carry. And the sum outputs are 1, 2, 4, 7 and the carry outputs are 3, 5, 6, 7. So here the input T is equal to 1 and the selection lines A, B, C and the outputs are 0 to 7. And each output we are obtaining the minterms. Now for sum output we are taken the corresponding minterms to the OR gate. For sum output 1, 2, 4, 7 and carry output 3, 5, 6, 7. So this is the implementation for full adder. Implement the following function. F is equal to 1, 2, 3, 7 using demultiplexer. So here the outputs are Y0, Y7 and the 3 selection lines. So we are selected 1, 2, 3 and 7 and it's connected to an OR gate and we will obtain the expression at this position. Implement the following function using 1:8 demultiplexer. F is equal to 1357. So here the 1 to 8 demarks. Then the outputs are Y0 to Y7 and the selection lines are A, B, C. The main terms are 1, 3, 5, 7 is selected and it is applied to an OR gate. So the expression we will obtain at this point is F is equal to 1357. Implement the following logical expressions using 1:8 multiplexer. Here the logical expressions is 0, 2, 4 and 7 is selected and it is given to the OR gate. So at this position we will obtain this logical expressions. Thank you.